Hello everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in statistical data representation, in this video we are going to see a case study based approach to data representation. So here our topic is data representation, unlocking the language of computers. So exploring how computers transforms human concepts into the digital language of zeros and ones. So let us see the introduction, why data representation matters. So data representation forms the foundation of how computers understand and process information in our digital world. Without effective representation methods, accurate computation, storage, seamless communication between systems would be possible. So this comprehensive case study explores key representation methods and examines their profound impact on modern computing techniques. So let us see the background, the digital language of computers. So as we all know that the binary foundation, binary structure and number systems are the basics of computer language. So binary foundation is computers operates exclusively using binary digits, simple zeros and ones. So next is byte structure, 8 bits combined to form bytes, the fundamental units for representing complex data structures and informations. The next is number system, binary, octal, decimal and hexadecimal systems. Each serve specialized roles in computing operations. The next is problem statement, challenges in representing diverse data types. So as we can see, there are many types of data we are inputting into the computer. So let us see how it is tackled. So data diversity challenge. So how can we efficiently represent vastly different data types from simple numbers and text to complex images and multimedia objects? The next one is system compatibility. So we have to ensure that our system is compatible for the data set we are using. Next is performance balance. So finding the optimal balance between storage efficiency, processing speed and computational accuracy for different applications. The next is methodology. So exploring data representation techniques. So there are many representation types. So here we are going to use binary system analysis, character encoding standards, complex data types and real world case studies as here. So comprehensive study of binary number system and proportional notations, principles underlying all the digital computations. So the next one is character encoding standards. So detailed examination of ASCII, ISCII and Unicode standards for text representation across global languages. Next is complex data types. So analysis of multimedia, spatial and structured data representation methods for advanced applications. The next is real world case study. So the practical example from digital systems, database and modern computing implementations. So key data representation concepts. So the first one is numerical data type and the next one is a text data. So representation as integers and floating points using spatial methods like sign, magnitude and complement and two complements for efficient processing. The next is text data. So as we have seen already, Unicode, these must be provided. The next one will be case example. So the binary representation and conversion. So decimal input, starting the decimal number 25, we apply the division and remainder method for conversion. Next is binary conversion through systematic division by 2, decimal 25 converts into binary representation 11001. Next is verification process. So the positional multiplication confirms accuracy. Therefore 1 into 16 plus 1 into 8 plus 0 into 4 plus 0 into 2 plus 1 into 1, which will be equal to 25. So that converts into squares and cubes. So the binary representation underpins all digital data storage, transmission and processing in modern computing systems. The next is solution and action plan. So what is the best practices in data representation? The first one is Unicode adoption. So implement Unicode standard for comprehensive global text compatibility across all international languages and character sets. The second one is two complement method. So apply two complement representation for efficient signed number processing and arithmetic operations. Next, hierarchical data models. So employ structured hierarchical model for accurate categorical data comparisons and analysis. Next is visual representation. So they leverage advanced visual data representation techniques to enhance human understanding and interpretation. So the next is results and outcomes. So impact on computing and data analysis. The first one is platform interoperability. So standardized data representation enables seamless interoperability across diverse computing platforms and systems worldwide. Next is enhanced performance. So the efficient encoding significantly reduces storage requirement while dramatically speeding up data process operations. The next is improved decision making. Enhanced data visualization compatibilities improve decision making process and facilitate clearer communication of complex information. Next is conclusion, the power of data representation. So the mastering data representation proves critical for advanced computing technologies and innovation. It serves as the essential bridge connecting human concept with machine processing capabilities. Future technological breakthroughs depend heavily on evolving representation methods capable of handling big data, artificial intelligence, and emerging computational paradigms. Thank you.